Practice now 5, question 2, yeah? So last call, nobody requires help for question 1. Okay? Given that tangent theta equals to negative 5 over 12. Okay, based on this, which quadrant is theta in? Theta in quadrant, just 4 only? Based on this statement. Are you sure 1? 2 or quadrant 4? Then they also tell us that, hey, tangent theta, oh no, they also tell us that 3 pi over 2 is less than theta, which is less than 2 pi. What does this mean? Okay, so for if you are still uncomfortable with radian, you can always do a quick conversion in your mind. When you see pi radian, what does that refer to? Degrees. 180 degrees, yeah? So 3 times 180, you can use your calculator. Then divided by 2? 270. Okay, so 270 degrees is less than theta, which is less than 360 degrees. Hey, this tells us it is in quadrant number 4. So based on these two pieces of information, I know that theta is in quadrant 4. And we are using radian for this question. Radians, huh? Evaluate sine theta and cosine theta without using a calculator. So since theta is in quadrant number 4, I need you to draw the x and y axis. I need you to be able to draw the angle inside quadrant 4. So it has to look like this first. Then continue. The angle, where is theta? This is theta. Once this is done, you need to form the right angle triangle. Okay, it doesn't ever stop here. You need to continue to form the right angle triangle. You have two options. First, you draw this black color dotted line. Second option, you draw the red color dotted line. Which one is correct? Red or black? I need everybody to be sure. Who thinks it is the red one? Red dotted line. Okay, the black dotted line? Nobody. Okay, that is the correct answer. Okay, it should be the red dotted line. It has to always look like this because that's how we've been defining our Trigo ratios with the triangles. Okay, so all of you make sure you have this drawn for question 2 in your textbook or wherever you've been doing it. Drawing the 90 degrees. Now with this, tangent theta is negative 5 over 12. Tangent theta is supposed to be opposite over adjacent. That's what you all learned in Sec 2. But in Sec 3, I didn't use opposite adjacent anymore. What did I use? Y over X. Right? And Y could be positive, could be negative. X could be positive, could be negative. Now in this case, since tangent theta is negative 5 over 12, are you able to tell me what these two represent? Yeah. Okay, tell me what is the... Okay, out of these two, the first one over here, where I have this x value and I have this y value, can you tell me which one is positive, which one is negative? Y is negative. How do you know? Because it's simply below the x-axis, right? So obviously this must be a negative value, and this is the positive value. So what is the value, what is the number I should be writing over here? 5. Then this one? Negative 12. Are you all sure? Sure? Are you sure? Are you sure this is 5 and this is negative 12? Which one is in the numerator? What is in the numerator? The y value, right? So what does that tell you about the y value, the numerator? It should be negative 5 over here. But, okay, here I draw the caret to indicate length, right? Class, listen. Over here, if you look at our textbook, and from what I said yesterday, the length over here is 5, this length, then the length over here is 12. But the coordinate, yes, this is negative 5. Okay, all these are coordinates. So you need to be very clear about the difference between coordinates and length. But for convenience, we will just write it this way. Okay, we just put a 12 over here, we put a negative 5. just for convenience. Can, Shan? Now with this, can you tell me what is the radius over here? How do you get 13? Pythagoras, okay. So now that we're using Pythagoras, does this degree sign matter over here? Yeah, because it's square, right? 12 square, 144, negative 5 square is the same as 5 square. Doesn't matter. So you do the square root, you will get square root 169 over here, which is 13. And it must be positive, okay? Now with our triangle, we need to write down what is sine theta. Sine theta is, so from our new definition, sine theta is given to be x or y as the numerator. Y over r, whereas cosine theta is x over r. Okay, let us use these over here. So what is the y value in this triangle? Is it 5 or negative 5? Negative 5. Negative 5 divided by 13. So we write this as negative 5 over 13. So in this way, we are able to write down what exactly is sine theta without using tangent inverse. Right? In sec 2, you probably will have tangent inverse to get an angle. Then after that, you sine the angle to get the answer. So, but this way allows us to do it without evaluating theta. And that is the whole point of this question. So last one, cosine theta. Adjacent, or rather, x value will be 12 over 13. Done. Okay, next one. I also gave you practice now 6, right? Are you able to do practice now 6, part A? If you write what? So you mean sine theta equals to O over H, is it? Then you write down 12 over 13, right? Okay, then when I see this, I will say that, oh, 0 over H is supposed to be equal to 0. So wrong lah. You get it? You get what I'm trying to say over here? Because when I am allowed to make a decision, my judgment is very bad. Okay, you have to always think that way for the examiner, for the marker. They may not give you the benefit of doubt. So in order to train you up, don't write O over here. Never do that because it looks like 0, which is used in mathematics. That is why for algebra, we never use let O represent the number of apples. What? Are you referring to this one? This one? Then what else is there? Italics? Zero dash? Which one? You find it, you tell me. Okay, for now, don't use O. Okay, next one. Last, focus. Practice now 6. A and B are in the angles in the same quadrant. So exactly what I have on the board, right? The approach is the same. Just that you need to know A and B are different angles, but they are in the same quadrant. Cosine A is negative 4.5, okay? Cosine A equals negative 4 over 5. Therefore, A in quadrant, what are they? 3 only? Or quadrant? How can it be 1? 1 or positive. So it's 2 or 3, Tangent B equals to 1/3, which is a positive value. That tells us that angle B is in which quadrant? Hey, why you all don't want to start from the smallest quadrant? Tangent B is 1/3. Tangent B is 1/3, so first quadrant. Or quadrant 3. Since both of them are in the same quadrant, what quadrants must A and B both lie in? So angle A and angle B in quadrant 3. With this, what do we need to do next? Draw. We need to sketch. Okay? in quadrant 3. So draw a dash down. Show me your angle A, going anti-clockwise. Is this a complete triangle? Can you complete the triangle yourself? Yes. Is the line you are supposed to draw vertical or horizontal? Vertical. Okay, so 90 degrees over here. Then we also have angle B in the same quadrant. Based on the information that we have, cosine A is negative 4 over 5. Does the negative sign belong to the 4 or the 5? Oh, okay, yeah, we can write the value. Okay, cosine, so we've got 4, we've got 5 over here, right? The x divided by the radius. So does the negative sign belong to the 4 or the 5? 4. Quite clearly it belongs to 4, because it's on the horizontal part of the x-axis. If I have two sides of a right angle triangle, can I find the third side? Yes. What is the side based on this triangle? 3. Okay, so we know that the magnitude is 3, but the sign is negative because it is below the x-axis. Now next, angle B. Tells that tangent B is 1 over 3. So, okay, you can use opposite over adjacent, but opposite refers to the x or the y value? Y value, okay, so there is a 1 over here. And 3, where does it go to?
The x value.
Okay, 3. Are you happy with this triangle?
No.
Does it look correct?
Yes, correct.
Do the values look correct?
No.
Then how should I adjust it?
Put negative sign on both.
Negative sign on both. Why must have negative 3 and negative 1? Because they are both in the third quadrant. And this is the negative x value, this is the negative y value. But originally tangent B is just positive, It's positive 1/3. Why are we introducing all these negative values? Will it still be positive 1/3? Okay, think about it. Originally tangent B is 1/3, it is a positive value. But now you're introducing negative and negative over here. Does it affect your tangent B being 1/3? Why? Yeah, negative divided negative, you get positive. So yeah, this is our correct triangle that we have. So with two sides, can I find the last side? Yes. What is the value? Square root 10. Positive or negative?
Positive.
Why positive over here?
Radius.
Because it's radius. Okay? So all these slanted lines, they refer to radius. Whereas the x values and the y values can have negative values. Okay? Depending on which quadrant they are in. So based on this, we should be able to very easily find sine A. Sine A equals to, what do you have for sine A? Negative 3 over 5. And tangent A. Okay, 3 over 4. Strictly speaking, it is negative 3 divided by negative 4, but it will simplify to become 3 over 4. Then next we have sine B. Okay, do we leave our answers like this in A Maths? Then how do we change it? Okay, like this, surds. What about the last one, cosine B? Cosine B, what do we have? Okay, and then we convert it. Okay, so these are the answers. Can? Next, we have worked example 7. Okay, now we are going to find trigo ratios given that cosine 35 degrees equals to A. Okay, find sine 35 degrees, cosine 145, tangent 215, cosine 55 degrees. Right, so can you tell the difference between this question and the previous one? There is algebra involved in all of them. Look at the previous question. Where is the unknown? This is known as angle. Okay, so is the unknown in the angle? Yes, right. Now look at the next question. Where's the unknown now? Is this still the angle? No, it is not the angle anymore. So this is our unknown over here. Darius. And our job is to find sine 35 degrees. In terms of A. So you are not supposed to evaluate A. I know all of you have calculators. You can just press cosine 35 degrees and get a value of A. But that's not what we want you to do. I want sine 35 in terms of A. Okay? So tell me everything you know about cosine 35 degrees equals to A. Darius, give me a fact about cosine 35 degrees equals to A. Any fact, anything that comes to mind.
Cosine 35 degrees.
Oh.
Adjacent over hypotenuse.
Okay, so it says cosine 35 degrees equals to the adjacent over hypotenuse. But I said I don't want to use adjacent and hypotenuse anymore, right? So how should we change this? X over R. Okay, so cosine 35 degrees is a ratio. It gives us a fraction. In this case, it will be X over R.
AR equal N.
AR equals to X?
I don't know.
Okay, hang on. So we are going to equate this with this one over here. Therefore, X over R must be equals to A, isn't it? But one is a fraction, the other is a just an A.
A over 1 more.
A over 1? Okay, let's do that.
A equals to X.
Okay, take note, this X over R is just a ratio. Ratios can be expressed in the lowest term. In this case, I can express it as A over 1 because we know that it's supposed to be equal to A and A is the same as A over 1. What does this tell us about the radius that we're using over here? What is the radius? Okay, this radius is positive. Okay, what is the value of the radius? No, over here, according to this, what is the value?
1.
It's simply 1. It is 1 unit for the radius. Then, how many units for X are there? 8. Can you sketch the triangle? Which quadrant does it belong to? 35 degrees. Which quadrant? Huh?
4. 1 or 4.
A. Did I say that A is positive or negative?
Yes.
Are you assuming that it is positive when you tell me 1 or 4?
So is it first? All.
Think about it. Are you assuming that A is positive when you told me that it could be in the first or the fourth quadrant?
Yes.
Is that a valid assumption? No, question never say. It is a very simple question. Which quadrant does it lie in? Huh? Are you sure all the quadrant?
No, I the alpha.
What alpha? What are you talking about? Look at the question. Cosine 35 degrees. Where is 35 degrees?
Like the first one.
First quadrant, no? Get it?
But 35 also got. The second quadrant.
Where got 35 in the second quadrant? This is my angle. My angle is 35 degrees. Where is 35 degrees? In the first quadrant. That's how you draw it. Hey.
Well, I think because they counting from the base.
We count from here. We start from the positive x-axis. We go anti-clockwise, and I tell you it is 35 degrees. So where must it be? First, second, third, or fourth? No choice. Why? It's the first quadrant already. The second quadrant will be more than 90. Okay, so right now we are able to draw our triangle. It is in the first quadrant, looking like this. Okay, so draw the line, draw a dotted line down, right angle, angle over here, this is 35 degrees. Okay, whenever you draw the right angle triangle, you have to find the sides. So have we determined the sides already?
Yes.
What are the sides that we have determined? Hypotenuse and adjacent. Okay, tell me what is the adjacent value? This one over here. This is A. Okay, and what is the radius? 1. If this is radius 1 and this is side A, what must this be? Okay, do it mentally. Tell me square root 1 minus A square. Can simplify or not this one? Cannot. So we leave it as this. Now, based on this, can you now tell me what is sine 35 degrees? How much is it? Sine 35? Over 1, which is square root 1 minus a squared. So that is it for our first question for sine 35 degrees. Okay? Then what about cosine 145 degrees? Why suddenly got 145 degrees? Okay, let's figure it out. So 145 degrees is in the second quadrant. This is our 145 degrees. And what has 145 degrees got to do with 35 degrees? They are adjacent angles on a straight line, right? So earlier on, we said that this was our 35 degrees. And we said that this was a, this is radius 1, this is square root 1 minus a squared. Right? Now I've got 145 degrees. Can you tell me how much is the basic angle for 145 degrees?
35.
Also 35 degrees. So this is 35 degrees. Can you now tell me what is the radius of this second triangle? How much is it? It's the same, huh? Same, 1. What about the this length over here? Negative square root 1 minus a squared? Positive or negative? Positive. Okay. And what about this portion over here? Negative a. So with this, are you able to tell me what is cosine 145? Cosine 145 degrees equals to negative a over 1. Okay, so the answer is negative a. Alright. This also reminds us of cosine theta equals to negative cosine 180 degrees minus theta. Okay, so this is another proof of what we have learned in E-maths. So next one, tangent 215 degrees. So we need to keep linking it back to our 35 degrees, yes? What? Or working very short, probably 1 mark, 2 mark question. Working very short, ma. Okay, back to this. Tangent 215 degrees. How do we relate 215 to 35 degrees? Okay, I heard somebody say quadrant number 3. So this is 215 degrees. But what is it got to do with our original question, 35 degrees? The basic angle is 35 degrees. Good. This is 35 degrees. So draw a dotted line again. What is the radius for this triangle? Still 1. What is the magnitude of this value over here? Okay. I asked for magnitude lah, so you're supposed to tell me square root 1 minus a squared. Then I'll ask you the sign, you will say it's negative. Okay? What about the x value? Negative a. So therefore, when I want tangent 215 degrees, I require my y over x value. So what's the y value? Okay, divided by x value. Okay, so simplify to become square root 1 minus a squared over a. Done. And the final one, cosine 55 degrees. Okay, this one is a little tricky. What has 55 degrees got to do with 35 degrees? With 55 degrees. Uh-huh. Okay. So in the first triangle, first quadrant earlier on, we said that this was 35 degrees. We had radius 1. We had this being a, right? And this was square root 1 minus a squared. 90 degrees. So where's my 55 degrees? So this one over here is slightly different. Here is my 55 degrees. Okay? With this, we are going to find out what is cosine 55. So here, do you think it is more appropriate to use cosine being x over r? Or is it more appropriate to use cosine 55 degrees is opposite, adjacent over hypotenuse?
X over R.
If so you see there are two options over here that I'm giving you. First, cosine 55 degrees equals to x over r. Second option, cosine 55 degrees equals to adjacent over hypotenuse. What will you choose? And why? Okay, what does this x refer to? This x refers to something along the x-axis, which is a, right? But when we use this formula, cosine 55 degrees is x over r, where must my 55 degrees be? Where must this start from? It must start from my horizontal, my x-axis, the positive side, and it must go anti-clockwise. Do I have 55 degrees over here? Don't have. Therefore, this x is not equal to a. Okay? If you like, you can draw the triangle again, but you are just wasting your time. You could draw this. This is 55 degrees. Then this is still 1. You have to rotate it. This will become a, and this will become root 1 minus a squared. But nobody wants to draw this, right? Waste your effort. Okay, don't ignore. Therefore, we can always fall back on what we learned in Sec 2. Adjacent over hypotenuse. If this is 55, where is my adjacent? Square root 1 minus a squared. Divided by 1. Hypotenuse. So this is square root 1 minus a squared. Okay? So let me just put on the result for sine 35 degrees. Early on we had sine 35 to be square root 1 minus a squared also. Okay, look at these two. What conclusion do you think you can draw from this? What am I getting you to discover? Okay, yeah, they are the same, but what is the relationship between this 45 and this 35? They add up to 90. Right? So in your right angle triangle, if this is angle A, this is angle B, this is your right angle, this being your hypotenuse, and let's call this side A, let's call this side B. Cosine angle A equals to adjacent, so that is B over hypotenuse. Then if I consider sine B, where B is this angle, so sine B opposite, B again, B over hypotenuse. Same. This happens when A and B add up to be 90 degrees. Similarly, we have sine angle A. How much is sine angle A? Tell me, in terms of ratio. Sine angle A over hypotenuse. A over hypotenuse. So cosine B equals to cosine B, A over hypotenuse again. So these are this is another relationship that we can find. Okay? Any questions? Who is completely lost? Resign. Okay, then please go on to do practice now 7. Okay, boys and girls. As you can tell, we require all 4 quadrants for all these angles, right? So I've already drawn the first quadrant on the board. I saw that some of you did something quite interesting. You drew all the angles in the same diagram. Let me attempt to do so. So over here, this is 50 degrees. Then drop a dotted line down. And we've got the sides 1, a, and square root 1 minus a squared. Okay? So what does it look like in the second quadrant? Remember, they must all be symmetrical. In the second quadrant, dotted line down. What is this angle over here? Because it is symmetrical, I know that this is 50 degrees. Therefore, my angle in black must be 130 degrees, yes. because it is symmetrical. If this is 130 degrees, what is the hypotenuse over here? It is still 1. What is the vertical length? Okay, the vertical side. A. What is the horizontal side? Okay, negative square root 1 minus a squared. So second quadrant done. Let's move on to the third quadrant. Because it is symmetrical, this will be a straight line. Because it is symmetrical. So from here I will draw another dotted line to the positive x-axis. Another 90 degrees over here. And now, what is the hypotenuse? It is still 1. What is the vertical side? Negative a. Do I need to do the horizontal side? It's already done, right? Because it is symmetrical. And the last side. Dotted line down. Wait, I forgot to write the angle. Okay, so the blue angle will be 180 plus 50. So 230 degrees. And the last one, the green angle. 360 minus 50, so 310. What is the hypotenuse? 1. What is the vertical side? Negative a. The horizontal side? It's written already. So with this, I can solve from part A, B, C, D. A, B, C, D. So check your answers at the back. A, B, C, D. Do you have any questions? Okay, wait. A, B, C, D. E. Okay, let's talk about part E. Anyway. Okay. A, B, C, D. Any problem? None. So let's move on to part E.
Do I need to square the answer?
No. Part E, where is angle 40 degrees? I will remove all this irrelevant information. 40 degrees is found quadrant. Okay, it is found in the triangle in quadrant 1. Over here. It's hiding over here. So tangent 40 degrees. Opposite. What is the side opposite the 40 degrees? 1 minus a square over adjacent. Done. Huh?
You should look at it from another angle. Because you are tangent 40.
Straightforward? Manageable? Who thinks it's manageable? Raise our hand. I need to get a few. Okay, thank you. Put our hands. I assume that if you raise up your hand, okay, and we will end off here. If this angle if this angle is alpha, and this is a symmetrical angle, what is the angle in red called? Okay, good. If this over here has the coordinate of x and y, meaning this is x and this must be y, right? Then what is the radius over here? What is this value? The radius. Okay, square root x square plus y square. And because I have another angle, a negative angle, I can do the same, right? So I draw this line down. What is the length again for the hypotenuse? Square root x square plus negative y square, which is the same as square root x square plus y square, right? No change. What about the y value? Negative y. Okay, and they share the same x value. Now we are going to investigate what is the relationship between cosine. Okay, let's start with sine. We always start with sine. Okay, sine alpha versus sine negative alpha. Let's look at the differences. What does sine alpha give us? What does sine give us? Sine alpha. Got negative meh? y over. Okay, what about sine negative alpha? Okay, so based on this, what is therefore the relationship between sine alpha and sine negative alpha? Okay, so from here, sine alpha equals to sine negative alpha, right or wrong? Wrong. What must I do to make it correct? Okay, done. Okay, next one. Let's talk about cosine alpha versus cosine of negative alpha. What is cosine alpha equal to? X over square root. Okay, good. Now, cosine negative alpha, what do you get? Are they the same? Okay, so this tells us that cosine alpha equals to cosine negative alpha. And we can use our calculators and put in values to verify very easily. And finally, we've got tangent alpha versus tangent negative alpha. I think you can figure this out by yourself and come to the conclusion that tangent alpha, is it equal to tangent negative alpha? No, there must be a negative sign. Okay? So this is the end of 8.3, which is quite a big topic. Yesterday we breezed through 8.1 and 8.2, so we spent a bit more time on 8.3. So now remaining time,